I welcome you all for this lecture series. Today we will discuss about case study in friction stir welding. It's a solid state welding where a modern and an environmental friendly process used to join relatively lighter family of materials, especially aluminum and alloys. So we have aluminum in abundant in earth, and most of the aerospace components are used because of due to its weight to density ratio and high lightweight and heavy strength. So the working principle of this friction stir welding is a cylindrical tool with a profiled probe is rotated and plunged into the joint line between two workpieces welded together. Friction heat is generated between the wear resistance welding tool and the material of the workpiece. Frictional heat is without reaching the melting point allows the traveling of the tool along the weld line. This can be well understood by the image here, where friction stir welding has made a remarkable process since its invention in the year 1991 by the Welding Institute, UK, in particular for welding aluminum alloys. So we have workpiece here and we have friction stir welding tool here. So here it is shown there is a self-reacting tool it is available that is called Bobbin tool friction stir welding. Although the process has many benefits, there are also drawbacks, one of them being risk of root flaws in single-sided welds. One of the most promising ways to avoid this is used to double-sided or bobbin tool, as this removes the root region. So, and benefits of bobbin tool friction stir welding is eliminates weld roots, root defects, low Z forces on the fixture, no backing bar required, low distortion due to uniform heat input, simple control and tolerance to thickness variation. So this is all about the benefits of bobbin tool friction stir welding. So what is the difference? Major difference we find here is it has root flaws in the welded joints. Since the pin does not penetrate completely with the material, we have some root flaws in the welded joints. Partial tool penetration, less heat affected zone, downward force present. In the bobbin tool friction stir welding, it has no root flaws, full tool penetration, large heat affected area, zero downforce. So whenever there is a downforce in the the specimen, and we have there is a distortion due to welding happens because due to the friction applied, the melting of plate takes place, and after the tool leaves the pass part, it starts to solidify. So due to that, we are getting some distortion if it is on the single side weld. Okay. Yes, we'll see the case study on this 7075 materials where these are applied in aircraft fittings, gears and shafts, missile parts, regulating valve parts, worm gears, aerospace and defense applications, automotive, right? And the composition is like this. And we have tool design for this bobbin tool is something unique. Today, we are very much interested on this specific tool design. So it has a shank and there is a pin in between two bobbins, right? These two bobbins are designed based on the thickness of the material. The exact 3D view is shown here, and the tool which is fabricated is being shown here. This is how a bobbin tool looks like. So based on the thickness of the material, the upper shoulder diameter and the lower shoulder diameter and pin length and pin diameter are calculated. Hope you understood how to calculate this bobbin tool and what is friction stir welding and what is bobbin tool friction stir welding. So thank you all. We'll meet in the next lecture series.